Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Polar Swirl by Lithium Ion, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. Digits along an arrow may repeat and must sum to the 2-digit number in the arrow pill, which is read either left to right or top to bottom. So, for example, you could have something like, say, this being 9 and 6, and this would have to be 15, because 6 and 9 add up to 15 here, and this would be a valid arrow here. Or you could have something like, say, 5, 9, 4, and 7. What does that add up to? That's not going to work. 4 and 8? Which adds up to 26, I believe. 5 and 9. Yeah, 5, 9 is 14, 4 and 8 is 12, so that would be 26. So this is another example of how an arrow could work, right? Because these 4 digits, 5, 9, 4, and 8, add up to 26. And the 2-digit numbers, the tens digit is always the leftmost digit or the topmost digit, and the ones digit is the rightmost digit or the bottommost digit. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, so all of these are 2-digit sums. If you have 2 unique digits adding up to a 2-digit sum, it must have 1 in the tens digit. So let's look for all of those. So we have this is 2 digits, so this must be 1. This is 2 digits here, so this must be 1. 2 digits here, so this must be 1. Now, for 3 digits, it's either 1 in the tens digit or it's 2. And you can add up to 24 for 3 unique digits, or for 3 digits as a whole, it could be potentially 27. Well, we know this can't be 1 because of 1 in the box, so this must be 2. Add the tens digit. This could be 1 or 2 here. We're not sure which. This cannot be 1 because of 1 in the row, so this must have a 2. 1 cannot be here. This is the sum of 3 digits, so this cannot be 1, so this is 2. This can't be 1. Also, the sum of 4 unique digits could be 30, but the problem is 0 is not a digit in normal Sudoku, so therefore it actually also has to have 2 as the maximum tens digit. So this is 2 for 4 unique digits. This is 4 unique digits, so it could be 1 or 2. This is also 1 or 2. This then has to be 3 or 4 to add up to all the remaining digits, not including the 2 digits that are in the arrow. So we could have 3 or 4 here. This is 2 unique digits, and you can't have a 2 here, so to add up with 4 unique digits, it cannot be in the 30s. It can't be 30 because no 0 is allowed in the puzzle, so this has to be 1 here. What digit is this? So the thing is, if this were 1, it would not add up to 20-something. Right? 1, 8, and 9 only adds up to 18. If it's 2, it can't be. So 1 and 2 can, in this box, cannot appear here or here because of 1 and 2 in the columns. So if we try to have 1 or 2 here, it's not going to add up to 20-something because 1 and 2 add up to at most 19 with 8 or 9. So this must not be 1 or 2. So 1 or 2 has to be here. So either this is 11 or this is 21. Well, this must be 23 or 24, adding up to with 3 unique digits. So this is guaranteed to either be 789 or 689. If this were 21, 21 plus 23 at minimum is 44. All 9 digits add up to 45, so they would guarantee you have a 1 here as the remaining digit if this were 21. But therefore, this cannot be 21, because 21 plus 23 at minimum means a 1 is here at maximum, and that's not allowed. So this must be 12, which makes this 1 there. So this is 12, this is 23 or 24. If it's 23 here, we don't have a 1 or 2. So 12 plus, okay, so to add up to 12, it has to be 3, 4, or 5. Adding up to 12, because we don't have 1 and 2 available anymore. So therefore, the remaining digit in this box is 6 or 7. We have a 3, 4, 5 triplet in column 1, which eliminates 3, 4, 5 in the rest of the column. So this is 6, 7, 8, and 9. This must be 23 or 24 because we have 8, 9 guaranteed with a 6 or 7 there. 5 has to be here, which means this can't be 5. Remaining digits in this upper left-hand box are 5 through 9. So this is a sum of 2 unique digits. So it cannot be 8 or 9 here. It's 15, 16, or 17, which means this can never have a 5. It's either 6, 9, 7, 8, 6, 9, 7, 8, 7, 9, or 8, 9 here. These are 5 through 9. So if this is 4 as a tens digit, the minimum would be 45, which 7 digits, unique digits, can never add up to. So this cannot be 4. It's 3 here, which makes this 4. 3 eliminates 3 in the rest of the column, so this is 4, 5 as a pair. 4 eliminates 4 here, so this is 3. 24 must be 7, 8, 9 added up together. So this is 7, 8, 9, which means this can't be 7. This is 6, which eliminates 6 in the rest of the column. So 7, 8, 9 adds up to 24. So this is 24 there. Remaining digits in this lower left-hand box are 3, 5, and 6. There's no 3 here because of 3 in the column. These 4 digits cannot include a 1. So they cannot be 13. It has to be at minimum 2, 3, 4, and 5, which adds up to 14 at least. So this is 15 or 16. We have a 5, 6 pair in this lower left-hand box, which eliminates 5 and 6 in the rest of the box. This cannot be 5 or 6. It's 3. This is the sum of 2 unique digits. Cannot be 1, 2, or 3 here. So this is 4, 5, 6, or 7. Which means this is 5 through 9 here. This also is at minimum 2, 3, 4, and 6, because it can't be 2, 3, 4, 5, because that would eliminate all possibilities for cells there. So this must be at least 15. So we have 15 through 19 there. If we have 35 here, the remaining digits in this row would actually add up to 45 minus 3 and 5, which is 37. So 5 does not work here. 6 does work. 37 does not. 45 minus 3 and 7 would be 35. So it has to be 36 here, which means this can't be 6. This is 5. That makes that 6. 5 and 6 eliminate 5 and 6 here, so that's 7, which means this can't be 7 here. This has to be 8, 9 as a pair, which eliminates 8 and 9 in the rest of the box. So it's a 7. 17, you must have 8 and 9 adding up to it. So this must be 5 here. So 36 plus 3 and 6 is 9, which adds up to 45, which is why that has to be 36 there. This is 16. This can't be 5 because of 5 in the row. Remaining digit, this adds up to, well, we don't know. 16. Can you not have a 2? The answer is no, because the remaining digits would be 3, 5, 4, 5, 7 at minimum, which is too large. So we need a 2 on this arrow because we can't have 1 available on this arrow. So 2 has to be here. That means the remaining 3 digits must add up to 14. Without a 1, 2, or 6 there. So 14 could be 3, 4, and 7, and 3, 5, and 6. Well, we already have a 6 in the row, so that doesn't work. So it must be 3, 4, and 7. So this 3, 4, 7 means that the 3, 4, and 7 are eliminated from the rest of the row and box. This can't be 4 or 7, it's 6. This can't be 6 or 7 here. 16 is the sum of 7 and 9 if it's 2 digits. So this is 7, 9 as a pair, which eliminates 7, 9 in the rest of the column. This can't be 7. The remaining digits in this box here have to be 5, 8, and 9. And 5 cannot be here because of 5 in the row. The remaining digits of row 8 are 4, 7, 8, 9. This cannot be 27. That would require 999 at minimum here. And it can't be greater than 27 because 3 digits can never add up to more than 27. So this must be 24. This can't be 4. 24 is... well, remaining digits of row 7 are 5, 6, 7, 8, and 9. This is at most a 9. So that means this must add up to at least 15. So you cannot have 5. Oh, 5 can't be any of these digits anyways. We have a 6, 7, 8, and 9 quadruplet in this lower right-hand box. That eliminates 6, 7... Wait, that doesn't work. This is also 3. That's why. 3 cannot be on this arrow, because 3 and 9 add up to 12 at most, which plus 9 is not going to add up to 24. So 3 has to be here. And 6 is one of these. Guaranteed, because there's no place for it in anywhere else in row 7. 6 and 9 at minimum add up to 15. Plus 9 is the maximum, which can add up to 24. Sorry, it's that maximum adds up to 9. To 15. So 6 and 9 means this is 9. Therefore, this must be 6, 9, and 9 to add up to 24. 9 eliminates 9 in the rest of the column, or sorry, row, which means this can't be 9. This is 5, 8 as a pair. This can't be 8 or 9. It's 7, which means this can't be 7 here. We have a 5, 8 here, which eliminates 5 and 8 in the rest of the box. This is 9. This is 8. That's 9, which means this can't be 8 or 9. It's 7. Remaining digits in this box are 5 and 8. If we have a 5 here, that adds up to only 12, so this has to be 8. That's 5. Okay. Where are the ones? 1 has to be one of these two. Where is there a guaranteed 2 on this line? It cannot have a 1. If we try to have 3 at minimum, so no 2, it would have to be 3, 4, 6, 7, because it cannot be 3, 4, 5, 6, because that would eliminate all possibilities for that cell there. And 3, 4, 6, 7 adds up to 20, so that's not going to work. So we have to have a 2 on this arrow, which means 2 must be there. Where is 2 in column 4. Can't be here because of 2 in the column or box. Can't be here because of 2 in the box. Must be here because it can't be here because can't add up to 16 with 2 digits. So we have 2 there. We should have 8 2s, which we do. We know where the last 2 has to be. It has to be there. 1s, we're still kind of restricted. 1 has to be either here or here. And it could be any of these 4. So we're guaranteed a 1 on this arrow, right? 1 cannot be here. It's guaranteed to be one of these 3 digits because it can't be here. Let's do remaining digits in column 4 then. 3, 4, 5, and 8. No 3, 5 here. No 4 here. Okay. 9 eliminates 9 here, so that's 7 and 9. 9 eliminates 9 here, so it's 8 and 9. Remaining digits in row 5. We have to have 3 through 7. No 3 or 5 here. So we're guaranteed 2 and 3 on this arrow. This can't be 7 because of 7 in the box. 2 and 3. Okay. Can you have 5? Well, 2, 3 is 5. So either you have 4, 6 adding up to 15, or something adding up to 18. So 18 minus 5 is 13. And we don't have 9 or 8 available, so it'd be 6, 7. So if it's 2, 3 adding up to 15 with these 2 digits, it must be 4 and 6. If it's 2, 3 adding up to 18 with these 2 digits, it must be 6 and 7. So we're guaranteed a 6 here, which means this cannot be 6 here. This can never have a 5. So where is the 5 in row 5? It has to be here. So this is 5, that's 4. So this is either 3, 4, 6 with 2, adding up to 15, or 3, 6, 7, adding up to, with 2, to add up to 18. 5 and 8 in column 4 have to be here. So then the rest of the digits in this box cannot be 5 and 8. So no 2, 5, or 8, which means 1, 3, 4, 6, 7, or 9. No 6 here, no 6 here, no 1s in either of these columns, no 9 here, no 1 or 7 here. This can't be 4 because of 4 in the row. So can you ever add up to 26 or 27 with a guaranteed 1 on the arrow? The answer is no. Because 1, 7, 8, 9 at maximum adds up to 25. So therefore, you can never reach 26 or 27. This must be 23, which eliminates 3 in the rest of the box. Well, that means we have a 4, 5, 8 triplet in column 4, which eliminates 4, 5, 8 in the rest of the column and box. This can't be 4, it's 7. This can't be 3. There's no 4 here. This is 3. This can't be 3 or 7. It's 4. This can't be 3 or 4. It's 7. So there's no 7 here, no 4 here. This is 1, 6, 9 as a triplet, which eliminates 1, 6, 9 in the rest of the column. 4 eliminates 4 here. So this is 6. Again, there's no 6 here. 4 eliminates 4 here. So this adds up to 23. With 1, that means the rest of the digits must add up to 22. So it's either 5, 8, 9 or 6, 7, 9. It cannot be 5, 8, and 9 because it would eliminate all possibilities for these cells here. So it must be 679 with the 1, adding up to 23. No 1 or 9 here, so it's 6, 7. This can't be 9. This is 8, which makes this 5. 8 eliminates 8 here, so it's 9, which eliminates 9 here, so it's 6. So this cannot be 6 here. No 5 here. 4, 8 as a pair. We have 5, 8 remaining in column 5. Remaining digits of row 2. We have 3, 4, 5, 8. No 4 here, no 8 here, no 3 or 5 here. Remaining digits of column 9, we have 4, 6, 7, 8. There's no 6 or 7 here. We have a 4, 8 pair in column 9, which eliminates 4 and 8 in the rest of the column. No 4 here. That's 7, which makes that 6. 7 eliminates 7 here, so it's 3 and 4. 2, 3, 4, 6 adds up to 15, so that's 5. That's 8. This is 5. Not 5, that's 8. 6 eliminates 6 here. 3 eliminates 3 here. We have a 4, 8 pair in row 2, which eliminates 4 and 8 in the rest of the row. This can't be 4 or 8, it's 5. No 3 or 5. Sorry, no 4 or 5 here. Therefore, that's 3. 8 eliminates 8 here, so it's 4, which makes that 8, which makes that 4, which makes that 8. Remaining digits in column 6. We have 3 and 5, and this can't be 3 because of 3 in the row, so this is 5, that's 3. Remaining digits in row 4. We have 1 and 5. This can't be 5 because of 5 in the column, so this is 1, that's 5. Remaining digits in row 6. We have 6 and 8. This can't be 8 because of 8 in the column, so that's 6 and 8. 6 eliminates 6 there, so that's 9 and 6. No 1 here, no 7, 9 here, so that's 1, which makes this 9, which makes that 7. 9 eliminates 9 here, so that's 1, which leaves this as a 6, and this, that can't be 6. We messed something up. Why do we have multiple 6s here? Oh. Right. How did I get those 9? Okay, so this 6 eliminates 6 here, so it's 9, that's 6. There we go. No 7, 9 here, that's 1, which makes that 9, which makes that 7. 9 eliminates 9 here, so that's 1. This is left as a 9, and this has to be a 4. Yeah, I kind of made a little bit of errors, but they're minor, so not the biggest problem. Anyways, I hope it made sense, the approach that I was going down. Yeah, it's basically, you have to notice where the restrictions are, and the restrictions really are on the tens digits in these pills. So you have to sort of attack that area. But you also have to attack areas where you could only add up to a certain sum, like this being 1, and another 3 other digits can never add up to 26 or higher. So those are things you can attack if you see those. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.